Hi, I'm Elizabeth Getz, representing the Golden Trio, which includes Daniel and Andrew. This is our design concept evaluation presentation. So first of all, our competition includes 4 robots competing every round to complete 4 different tasks. First of all, to remove Nifflers and Dementors from the zone, collect shiny objects, and then to imprison Grindelwald. So in order to create our designs, we have to go back to our design tools. First of all, with our Haskell quality, there are 4 main categories. And we also have 4 major categories to think about with engineering requirements. Then this leads into our specification sheet where we have 3 major categories: geometry, operation or cycle time, and ergonomics and maintenance. Then we have our function tree, and this function tree has subfunctions which lead into our morphological chart where we come up with the different design solutions. And from this morphological chart, we create our design concepts. Our first design is from our week 9 competition robot, where we have a base with 4 supporting mass, and 4 drawer slides, 2 on each side. Then we have a shiny object collection box with a Niffler sorter and a Niffler chute. With the Niffler sorter, it's just high enough that the jumps can slide underneath it, but it directs Niffler balls to the Niffler chute. It's all activated by a pneumatic cylinder. And this is a very successful design because it scored 96 at the competition. Even though it's not perfect, it can be easily improved and calibrated, but it does need more subsystems to be successful in actual competition. Our design 2 is based off of week 10 competition, where again we have the drawer sides, and instead we have a Grindelwald catapult at the end. This uses mouse traps to swing it forward and a motor or solenoid to hold the catapult back until it's needed. We also added in a Dementor scooper that will retract the Dementor back into the home zone, or back into the robot. The caveats to this design are that we found that the base is not as efficient to maintain, and we have not worked with the Dementor scooper or prototyped any of that yet, so we don't know how that will work necessarily. With our design 3, we have a telescoping arm with a different form of collection box at the end, and Niffler sorter. It's just a vertical version of that, so the gems fall through a slot, and the Niffler balls will once again roll out through the Niffler chute into neighboring zones. We also have sweeper arms that use motors and gears to power them. This design has a few different problems with it. First of all, a telescoping arm is hard to work with, and gears are hard to work with. We haven't prototyped any sweeper arms yet, and the base isn't as stable as some of the other designs could be. Our design 4 is based off of our design 2. We added in blocking arms. So once again, our Grindelwald catapult works, but we don't know how our Dementor scooper works. We're not exactly sure how the base is more ergonomic than it was before, and we haven't worked with blocking arms before. These are supposed to prevent any balls or bones from getting into our zone. And these will work by falling down once the extension arm has been activated, so it pushes the arms down. Then we have design 5, which is pretty much the same design as design 4, but we took out the Dementor scooper and added in our Niffler and gem sorting mechanism. This will help this design because we have 2 known working subsystems in it, the Grindelwald catapult and that gem Niffler sorting mechanism, and we only really have to work on improving our blocking arms. And once again, we put back in the base with 4 supporting mass, which we think is more stable and easy to work with. So then we take all of the designs and we look at them in our first level evaluation matrix. And here we compare everything to our week 9 robot, because that's our datum. And here we find that the week 9 robot, our first design concept, is the best. This is because you can see in the sum of all the worse than datum points, all the robots have a lot of those negative values, and therefore we can assume that our week 1 and week 9 robot is better than all the rest. But we can take this step further into our second level evaluation matrix, where we rank all of our robots on a score of 0 to 4, 0 being unacceptable or it does not perform a task, and 4 being very good, it does a task very well. And here we find that our design 5 concept is the best design, but it's not the best by a lot. It has a score of 34, while our week 9 concept 1 robot had a score of 33. So we add in a weighting with our third level evaluation matrix. So we go back to Haskell quality, find the importance of all of our criteria, and we find that our concept 5 is again better, but it's better by a larger amount. It has a score of 225, while our first concept in second place, design, has a score of 218. So therefore, with our conclusions, we can conclude that our our concept 5 robot is the best design, but there could be some other improvements with determining which subsystems work the best.